Our 8th lecture video on temperature and heat will cover expansion of liquids. Since liquids don't really have a set length or area, we will instead be calculating their volume expansion. The volume expansion in liquids, or delta V, is equal to beta times V times delta T, where beta is the coefficient of volume expansion for liquids, which you will find online or in a table. V is the original volume, and delta T is the change in temperature. Remember, this equation will only give you the change in volume, not the new volume. Let's look at one volume expansion of liquids example. If some petroleum has a volume of 3,950 gallons at 60.0 degrees Fahrenheit, what is its volume at 0.0 degrees Fahrenheit? First, we will write down what we know. Since we have petroleum, the coefficient of volume expansion will be 5.33 times 10 to the minus 4 per degree Fahrenheit. The change in temperature, delta T, will be 60.0 degrees minus 0.0 degrees, which is 60.0 degrees Fahrenheit. The original volume, V, is 3,950 gallons, and we are trying to find delta V, the change in volume. The units on delta V will be gallons, since the original volume was measured in gallons. The basic equation we need to solve this problem is that delta V equals beta times V times delta T. Substituting, we have delta V equals 5.33 times 10 to the minus 4 per degree Fahrenheit times 3,950 gallons times 60.0 degrees Fahrenheit. This gives us a change in volume of 126 gallons. However, the question is asking for the volume of the petroleum at 0.0 degrees Fahrenheit, not what is the change in volume. Since we want the new volume after the petroleum has cooled, we will take the original volume and subtract the change in volume. Again, we will subtract in this problem because we are cooling the petroleum down, not heating it up, so the volume will decrease as we cool it down. So we can take 3,950 gallons minus 126 gallons, and this gives us a new volume of 3,824 gallons. This concludes our discussion on the expansion of liquids.